In this example, we are going to find the average function value for the function f of x equals x to the third minus 5x squared plus 30, which represents the elevation of the path. In this example, the problem given us the elevation of the path is as a function f of x equals x to the third minus 5x squared plus 30, where x measures the horizontal distances. We're going to find its average value for the x between 0 and 4. To find the average function value, the formula is f bar of the x equals 1 over b minus a multiplied by the definite integral from point A to point B of the function with respect to x. In this case, the a is 0 and the b is 4. Then the average function value is 1 over 4 minus 0 multiplied by the definite integral from 0 to 4 of the function x to the third minus 5x to the second plus 30 with respect to x, or 1 over 4 multiplied by the antiderivative of the three terms for the integrand. For x to the third, we get x to the fourth over 4 minus the second term 5x to the third divided by 3, and the last term we get 30x, and evaluate from x equals 0 to x equals 4. Now replace the value for the upper limit x equals 4. The first group we get 4 to the fourth over 4 minus 5 over 3 times 4 to the third power plus 30 times 4, and then subtracted by the quantity from replacing x with a 0, which is 0. Then we simplify the number and get the answer as 58 divided by 3, or the number is about 19.3, repeating. For this problem, that means the average function value is 19.3, and we can represent it with the graph as the graph. This is the curve of the function f of x equals x to the third minus 5x to the second plus 30, and it's bounded. We find the area between 0 and 4. So this is x equals 0, this is x equals 4. The area under the curve between the curve and the x-axis from x equals 0 to x equals 4 is represented as the shaded area in yellow. The average function value that we just computed is the function value, or the f bar, equals 19.3, repeating, or about 19.3. If we look at the area of the rectangle with the height as the f bar and the width as b minus a, or 4 minus 0, so the area of the rectangle is the same as the area of the region bounded by the curve and the x-axis. The next example, the surface of the water wave is described by the function y equals 5 times 1 plus cosine x for x between negative pi and pi. Find the average height of the wave. The key term, the average height, and the height represented by the y function. So the average height of the wave equals 1, let's say use the term the y bar equals 1 over b minus a. The a is negative pi, the b is pi, so from pi minus negative pi, and then that's the denominator, and then multiply by the definite integral from negative pi to positive pi of the function, which is 5 times 1 plus cosine x with respect to x. Simplify the term as pi minus negative pi give us 2 pi, and then the definite integral from negative pi to positive pi of 5, so 5 as a coefficient, we're gonna clean up the coefficient, like combine them together, not combine, like simplify the coefficient as 5 divided by 2 pi, and the integrand is now just 1 plus cosine x with respect to x. Notice that the lower limit, upper limit in the form of negative a and a, we just think about the odd even function property. So we're going to consider odd even function property. For our case, we look at 1 plus cosine x. Ask yourself question, is that an odd or even? So the answer is an even function. You can verify it by if f of x equals 1 plus cosine x. If you replace the x with the negative x, 1 plus cosine negative x, that returns exactly the same as the original function. Or you can use the graphing calculator to verify the graph. If you see the graph symmetry about the y-axis, that is the graph of an even function. So now we verify this is an even function. Then we use the even function property that the net area is twice of a half of the area. So we rewrite it as 5 over 2 pi multiplied by 2 times a half of the net area, which is from 0 to pi, of the integrand 1 plus cosine x with respect to x. 2 and 2 reduce. The coefficient now simplified to be 5 over pi. The antiderivative of 1 plus cosine x is x plus sine x. Evaluate x equals 0, x equals pi. Replace the value, the upper limit first, that is pi plus the sine pi, subtracted by 0 plus sine at 0. The sine at pi and sine at 0 equal 1, equal 0, sorry. So then the answer come up to be 5 over pi multiplied by pi, or just 5. So we get 5 as the average height of the wave. To represent it using the graph, the graph here is a graph of y equals 5 times 1 plus cosine x, or the graph of the cosine with the vertical shift 1 unit multiplied by 5, as the magnitude of the graph is by the factor 5. And the area about it from x equals negative pi to positive pi. And as you see the graph, it has symmetry with respect to the y-axis, or the left area equals the right area. We found the average function value, the y bar, as a value 5. It can be explained by the area of the rectangle with the height 5 and the width 2 pi is the same as the area under the curve of the function y between the y and the x-axis, or the yellow area equals the green area.